Good morning, good afternoon, good evening. My name is Jean-Daniel Lécuyer. I'm the product manager of Marc, and I'm pleased to present you today the new functionalities and the enhancements associated with the release 2025.1. For people who don't know, so Marc is the first commercially available nonlinear simulation software with more than 50 plus years of development. It's a structural simulation solution with strong multiphysics capabilities. It covers a comprehensive nonlinear material model library, and it has unique capabilities such as automatic remeshing, hybrid contact, other specific capabilities around contact, that excels at failure and damage analysis. Marc empowers CAE experts with comprehensive and robust multiphysics analysis capabilities that they can perform all types of nonlinear structural simulation and take advantage of cutting-edge technologies. Let's look now at the new capabilities and the updates with Marc 2025.1. I will first talk about previous analysis state improvements. I will update you on the hybrid contact formulation. I will introduce you as a new subroutine called Umaterial. I will show you user experience enhancements in Mentat, and finally, we will discuss about the new documentation framework. So the hybrid node-to segments algorithms is the recommended one for any contact modeling approach. It has been introduced in earlier releases, but it has been further enhanced in this one. So now it is set as the new default for structural analysis. This new approach activates a double-sided contact formulation that is primarily penalty-based. Many advantages are associated with this hybrid approach. You will have a true double-sided treatment of contact, reducing the need to manually distinguish between primary and secondary bodies. You will have a better treatment of multi-body contact. You will have an improved separation behavior. You will have the possibility of having a 3D representation for shells for contacts. And we have also introduced with this release the ability to use nodes on a geometric contact body to avoid geometric body penetration in a deformable contact body. At the right-hand side, you have an example, a lift spring simulation showing great results with the hybrid node-to-segments formulation versus the standard node-to-segment formulation. As you can see, the speed-up ratio are just amazing. In the user guides, you will find an example, E46, where we will use this new capability of defining a geometric contact body with nodes. This is especially useful for this case because of the right angle with the green parts. Please have a look at this example in the user guide if you are interested by this approach. A new user material subroutine called Umaterial has been introduced. The iPlateau subroutine has long provided a way to define users' material when built-in models were insufficient for capturing complex mechanical behavior. However, this iPlateau subroutine was often cumbersome with limited documentation and few practical examples. This new Umaterial subroutine introduced a new and improved way for defining user-defined materials. It has been designed to offer a more accessible, flexible, and user-friendly experience. You will have a better control over near compressible and incompressible materials. You will be able to pick and choose from predefined nonlinear integration schemes. You will be able also to focus only on defining the deviatory behavior, while Marc automatically will handle the volumetric response. And finally, we'll give you the access to a set of utility routines designed to accelerate the development of a custom material model. We provide you two use cases in the user guides, the E48 and the E126. Please have a look. One is dedicated for von Mises plasticity and the other for rubber behavior. Let's move now to the previous analysis state improvements. The so-called pre-state functionality enables users to reuse simulation results as initial conditions for new analysis. This has been improved 1 year ago with Marc 2024.1, and we have removed in this release known gaps, such as the possibility to use multiple post files from various upstream analyses, including different formats, as you can see in the slide. We have improved the performance when dealing with model decomposition. Downstream simulation models can now use a larger region than the model from the upstream simulation post files. We provide options for the data mapping to separate this mapping between the different contact bodies, and shell elements are now supported. Here is an example on how we can use this pre-state capability. Here, the upstream simulation has been performed with Simufact forming, with a sheet metal forming simulation. All the results will be reused for downstream analysis with Marc to perform a Springback analysis. User experience has been also enhanced for the graphic user interface for Marc called Mentat. First of all, the lighting effect has been improved so that we have no more excessive reflection. We redefine the light sources, the ambient light, so that we have now a great and pleasant look and feel. The trial has been changed also, so now it is displayed with solid red, green, and blue arrows by default. As you can see with the video, all the colors are adjusted depending on the theme that is selected, depending if this is the traditional one or the dark one. An improvement has been made also for boundary condition management. A new menu named Usage of Boundary Conditions has been introduced to simplify the activation and deactivation of boundary conditions across various load cases and jobs. This reduces obviously the risk of incorrect simulation scenario definition. This will allow you to apply newly created boundary conditions to all existing load cases, for example. And in general, this should improve the efficiency and the usability of boundary condition assignment for load cases and jobs. The next improvement I would like to discuss is around post-processing and cutting planes. So you were able to create contour plots on intersections of the mesh with one or more planes. This is useful for post-processing results in the interior of 3D solid models. Previously, those cutting planes could only be defined by translation from a first plane using a spacing parameter. A new rotation-based method has been introduced, and this new method is especially valuable for post-processing analysis with models containing axisymmetric or close to axisymmetric arcs. Some other enhancement has been introduced in Mentat. You have a new output that is made available for stress triaxiality. We improve the sets right-click menu, mouse right-click menu, by adding the Add Entries option. We added a new filter for the Select Post Scalar or the Select Post Vector menus. And we introduced a new button links to Nexus Compute from the graphic user interface to directly connect to our cloud computing solution. Finally, I would like to discuss about the new documentation look and feel. So the Marc documentation has been redesigned to ensure a visual consistency across all Hexagon CAE products. The traditional PDF files have been replaced with an interactive HTML format. This should allow you to easily navigate through volumes and sections, and you will be able to define and manage favorites, and you will be able to get access to specific search capabilities. I would like now to remind you some recent improvements that have been made in Marc and Mentat, and especially for the 2024 releases. We have introduced new capabilities, such as fluid pressure penetration modeling, such as temperature-dependent superelements, such as the Ashigushi Advanced Nonlinear Friction Model, or recession with multiple pyrolysis material layers. We have also improved the performance of our solvers, for example, with multi-threading support for radiation. We have also introduced the user experience for Marc and Mentat by introducing the units for pre-processing. For additional information, please have a look at the Marc dedicated pages in Nexus Home or in Sim Companion. Thank you and enjoy using Marc 2025.1.